After inflation, another important aspect is the compounding, which is the key driver in time value of money. Compounding is a fundamental concept in finance that refers to the process of earning interest or returns on an initial sum of money, the principal value, and the previously earned interest or returns. In other words, to simplify, compounding involves reinvesting the earnings or gains to generate additional earnings in subsequent periods. Formula is that one. So you have future value, N, for the number of the years, equal to the present value today, times 1 plus I, yearly interest rates, divided by the M. M is the number of the periods in year. All power to the M multiplied by N. M, number of the periods, N, number of the years. Compounding has a powerful effect on growing the value of investments and savings over time. The longer the time period, the more significant the impact of compounding. Let me show you how it works in practice. In this case study 23, we shall use the compounding. The following case study will show how the compounding is working in practice. Bank and financial institutions use semi-annual, quarterly, or monthly compounding for various financial products to make them more attractive to the customers, to you. Company X here invests $1,000 in the period of 2 years with a 12% yearly interest rate. Yearly, keep in mind. Calculate the return if investment is compounding on an annual, semi-annual, quarterly, monthly, and daily basis. Let's see it. Step 1, the usual formula. Future value equal to the present value times 1 plus I, annual interest rate, divided by M, number of periods in year, all between brackets to the power of M, number of periods in year, times number of the years. If we start here with the annual compounding, so $1,000 present value times 1 plus 12% divided by 1 because it's annual, 1 period in year, to the power of 2, 1 period in year times 2 years, and you will get $1,254.40. If we continue, we apply the same formula but for semi-annual compounding. So what is different here? You see between brackets it's 1 plus 12% divided by 2 because you have 2 semesters. You have semi-annual compounding, 2 semesters in 1 year, it's 2. To the power of 2 semesters times 2, so it's 4 semesters in 2 years, equal to $1,262.48. In step 4, you have the same story but quarterly basis. So your annual rate of 12% between brackets, you divide it by 4 quarters in 1 year to the power of 4 quarters times 2 years, so 8 quarters in 2 years. And it brings you $1,266.77. If you do the same for the monthly, so the annual rate you divide by 12 because you have 12 months in 1 year, to the power of 12 months times 2, 24 months in 2 years, and you obtain the higher, obviously, value here, which is $1,269.73. In step 6, the last one, you see it, the same story, but with the daily compounding. So the annual rates you divide between brackets by 365 days to the power of 365 days times 2 to get the number of the days in 2 years, which gives you higher amount of $1,271.2. As you can see, the compounding on different bases here, annual, semi-annual, quarterly, daily, affects highly returns. Faster compounding, higher returns. And in most of real life cases, you will have, keep in mind, the annual compounding.